So today we will be discussing about the MSE wall module in GEO5. So I'm just open the MSE wall module from GEO5, and in this I will be explaining you the basic design of the MSE wall. So the interface will be bit similar with how it will be in the other modules. So we will start from project. There we can give some project data like demo 1, or else we can describe what is the project data, who is the customer, and project ID if we have. Next, in settings we can select on what standards we have to be designed, limit state design or Eurocode design approach 1, 2, 3, or Indian standards, whatever we want. So in this demo I'm just taking a standard factor of safety, and after that moving to the geometry, I am considering the basic details of number of blocks as 20. That means how many number of blocks we have to be assigned here, and each block height is 0.2 I'm taking, and block width 0.5. So block offset, instead of 0 I'm taking 0.05. That means I'm taking some inclined, it will be not straight. So now we can see that how it is. And after that, material properties of these blocks, I'm taking unit weight as 23, coefficient 0, and no friction, and shear bearing capacity of joints. That means shearing between these two blocks, I'm not considering any shearing happen. That means 0, no resistance. And after the type of reinforcement, I'm just adding the type of reinforcement here. So So we can select which type of reinforcement we want to be added. I'm taking a grid reinforcement with 5xt, 5xt, and so here we can select which type of reinforcement we have to be checked. I'm taking 5xt directly. So the properties of that reinforcement, what is the tensile strength, and other details will be taken directly here. I'll just add it and close. Now you can see the reinforcement is assigned here. After that I'm moving to the reinforcement block. Here I will be assigning, that means for which we have to be assigned. So we will go to generate, and continuous length is 3.5 meters. So here we can see all the reinforcement, but I'm just considering the alternatively. That means at the first block reinforcement, second block I'm just removing. That means I can edit it here. Sorry, I'm just removing all the reinforcement. I will assign again. Go to generate. Initial block 1, final block will be 20. Repeat after, instead of 1 I will make it 2, taking grid continuous identical to the reinforcement 3.5 meters length. Okay, So then it will be assigned alternatively. If we give 1, that means it will be assigned for each and every block. So once it is assigned, I will go to the profile. I will take the soil properties here. So for that, I'm taking a single soil layer for the demo purpose. So I'm taking gravelly silt. I'll take the same properties, which is unit weight 19 and internal friction 29 and cohesion 8 and friction of angle substructure, let us take 10, and unit weight of the saturated soil as 90. So I'm just changing the color code just for identification. I added the soil here and I will be assigning the same soil here. So after that I will be assigning the terrain type. That means here we can see what is the terrain type. That means the soil is with some certain angle, or it is having certain angle, and after that it will be flat and with the other different geometries. In this I am considering beta is equal to 0, that there is no soil beyond the wall. After that, water table. Here we can consider the water table backside of the wall. So in this design I am not considering any water table. And surcharge load, here we can assign the type of surcharge loads we have. So I'm adding a load combination here. Surface load and permanent condition with a magnitude of 35 kilonewton per meter square. So the load we can see here at the top. Now we will check the FF resistance. That means on the other side, we have, if we have any soil considered, I'm not considering any soil on the other side, and I'm not applying any of the point loads or applied forces on this. So directly we'll jump into the verification. Here we can see the water turning is satisfactory with 5.2% and slip is satisfactory with 15.9%. Similarly, the dimensioning also satisfied here. So whole wall bearing capacity analysis we can check here, and in the bearing capacity we can check stresses in the foundation bottom we are considering as a rectangle, and here ultimate bearing capacity of the foundation soil we have to assign manually. That means whatever based upon the type of the soil we have to calculate and we have to assign, or else we can have the other GEO5 modules which will be related to the considering the capacities of the foundation here. So there we can launch the program and check the species directly. So with 150 it is not satisfactory. It should be 175. Yeah. So with the with 175 it is satisfied. Foundation soil also safe, and slipping sorry yeah slipping geo reinforcement we can check. This is also satisfactory. That means it is passing, and we can check the internal stability here. Yes, strength and pull out resistance or pull out also it is satisfying. Here we can check the global stability. That means we can check the whole stability of this setup just by running the analysis. So in this analysis it will be considered the Bishop's method, which is by default it will be selected. If you want to change we can change that, and here it is selected as the optimize option, where we already discussed about this in slope stability analysis part. So now here we can see the slope stability check also done, and we are getting the factor of safety of 1.59, which is greater than 1.5. Now if we want to check the stability in slope stability module, we can check this similarly how we used to do it earlier. We can run the analysis by considering the Bishop's method and taking the analysis type as optimize, and we can run the analysis in slope stability module also, and we can save it and exit from this module, and we can go back to the MSE wall module, and that analysis will be saved there. So with this we can check the stability of the MSE wall considering the reinforcement and other details. Yeah, this is safe with 1.59 factor of safety. I'm just exit and save it, and with this the wall is safe in all the conditions like bearing, slip on geo reinforcement, and internal stability is safe, and global stability and stability of the earth also. With this the analysis will be done.